beginning, adding and subtracting polynomials. Chapter 8 is about polynomials. Mostly what we're going to be working with specifically are quadratics, but we're going to have polynomials is what we're dealing with. The first setup, this first day, is actually fairly simple. We do two things. We're going to learn about the names and how to write polynomials, and then adding and subtracting them. Really easy today. We start out easy. It's going to get hard in a hurry. Okay, one of the things that mathematicians like to do is to give names to very common things. Polynomials have names based upon two things, based upon how big they are and how many terms are in them, and we'll talk about that here. Standard form. There is a particular way that you should always write your polynomials. You should always write your, how you have it set up. When it's just one term, which is what I have here, 12, standard form, hey, there's not a lot I can do to that. Okay, standard form is 12. I got one thing, it's just that thing. There's nothing else I can do with that. Okay? There are two other things that we have to concern ourselves with. The first one is degree. Degree is actually very easy. The degree is the largest exponent on your variable. Now, in this first term, do I have any variables here? No, so the degree on my variable, the variable I have, I don't have a variable. My degree is actually 0 on that one. Okay, if I have no variable, it's a polynomial degree 0. I've got one term, I've got that. I have a special name for something in that degree. I should say the first 3 degrees have special names, or 4 degrees have special names. You need to know them. If I have a degree 0, I have a constant. That's fairly simple to remember because I have one thing. I have a constant term. 12 does not change. No variable, it's constant. Variable means it can change. No variables means it doesn't change. It's a constant. Okay. Now the next question I have is how many terms do I have here? I've got one term. We have special names based upon the number of terms. If I have one term that is a monomial. Sorry, there's not a lot of room to run on that one, but it's a monomial. It's one term, it's a monomial. Mono for one, right? Makes sense, monomial. Didn't talk a lot about standard form of the first one because there's one term. Standard form is that. When you start having variables, that's where standard form becomes more important. Your variables always come first. Highest power followed by next highest power followed by next power, all in descending order until you have your constant in the end. So 8 plus 7x is not in standard form. It should be 7x plus 8. That's standard form. Variables first. Any non-variables at the end. Pretty easy to remember, right? What's my degree on this one? What's the highest power of x that I have? 1. I have, remember, we don't write a power, we have a 1, so this is degree 1. If it is a polynomial degree 1, that is a linear equation. We've been working with polynomials. When we did all our lines and stuff, those were all linear equations, those were linear polynomials. That's what they are. How many terms do we have there? We have 2 terms. So if one term is a monomial, what do you think 2 terms are going to be? Come on, mono, 2 terms would be a binomial. Okay, yes, question for. All right, so the next one here. Standard form, highest power comes first. What's going to come first? Yeah, the y squared is going to come first, followed by the next highest power on the variable. So I'm going to have y squared plus 2y. And then don't forget this. Often students lose the negatives. They disappear on them. Minus 4. Standard form. Highest power followed by next highest power all the way down until you have a constant. And if you're missing a power, that's okay. Just skip it and go to the next one. So if you have squareds but no single powers, that's all right, not a problem. What's our degree? What's the highest exponent? 2. This is degree 2. This is most of what we're going to spend our next couple of chapters working with. These are called quadratics. Q-U-A-D-R-I, quadrat. Let me start over. Quadratics. Q-U-A-D-R-A-T-I-C-S. Quadratics. We're going to spend most of this chapter and most of the next chapter dealing with quadratics. In fact, almost all of the next chapter is quadratics. And almost all of the rest of this chapter is quadratics. It's a big part of Algebra 1 is dealing with quadratics. What's our degree on this one? Or sorry, what's the number of terms? We did the degree. How many terms do we have? How many terms do we have? Come on, I know it's Monday, but please. You can count. 1, 2, 3. You got 3 terms, right? If 1 term is a monomial and 2 terms is a binomial, 3 terms would be a trinomial. Getting a little more complicated here, but it's not bad. Is the next one in standard form? Is this one in standard form? Got the highest power first, right? Is it in standard form? Almost. First 2 terms are good, but the last 2 are not. Remember, it's always in descending order of powers. In standard form, this would be 2x cubed plus 4x squared plus x minus 1. It's almost in standard form, but not quite. You just lost the last 2. What's our degree? What's our largest power? 3. Largest power is 3. So we have degree 3. And this is a cubic. C-U-B-I-C. Cubic. Because the highest power is a cube. It's a cubic. I don't know where the term quadratic comes from. I don't really care. How many terms do we have? 4. Got 4. Ooh, monomial, binomial, trinomial, polynomial. Anything more than 3 is a polynomial. At some point, we stop naming them special. This is a polynomial. Poly for many, polynomial. Anything more than 3 terms, we just call it a polynomial because technically you could have 40, 50, 60, 100 terms. We don't know how many. We're not going to come up with that many new names. Yes?
What's the names for the ones that you showed us?
Because we use them so much more. Really, you use linear equations. We did a whole chapter dealing with linear equations. We've actually done 2 or 3 chapters with linear equations. We're going to do a couple of chapters with quadratic equations. You use them so much, they show up so much more often, you get special names for them. That's really what that is, more than anything else. At some point, you're like, okay, we don't do this very often. You don't deal with these ones very often. We're just going to call everything after here polynomials. But these ones happen so much more in everything we do. We're going to give them special names because we see them all the time. Does that make sense? At some point, you know, there's an infinite number of things. There's only so far you can get. And I imagine there are some names for some of these, but at some point they just said, hey, we're just going to call them polynomials. It'll be good. We call it special names because we just use them so much. Okay, last example we have here, once again, put it in standard form, which means our negative 9x, be careful, students tend to drop the negatives if it's in the middle here when you rearrange it. Negative 9x to the fourth, and then plus 6x squared, and then plus 7. And then what's our largest degree on this one? 4. We have 3 terms, but the largest power is 4, so our degree is 4. You can have one term and have a degree of 100. If it's x to the 100th power, that's one term to the 100th power. So I have a 100-degree polynomial. It's technically one thing, but okay. We do not have a special name for this one. Once we get past 3 on our powers, we just start calling them polynomials. We don't have special names for anything over a third degree or over 3 terms. How many terms do we have here? 3. So we're back to 3. We do have a special name for this one. This one would be our trinomials. We're going to use these terms a lot. You do need to understand the degrees. They come in important more later. The big thing out of this one is understanding the difference between a linear equation, a quadratic equation, and a cubic equation. And we're going to spend a lot of time working with quadratics this next couple of months. A lot of time in quadratics next couple of months. I'm going to say quadratic, which means you're going to know the highest power is squared. You have to be able to understand that. When I say quadratic, you have to understand what I'm talking about. Okay? Okay, this part's easy. Shouldn't take you more than a couple of seconds. What is the degree of each polynomial? So what is the degree on this first term here? 1, because I have x to the first largest power, degree 1. What's the degree on this one here? 7, highest power, 7. What's the degree on this one here? What's the largest exponent? 3. So my largest exponent is 3. I have a degree 3. Technically, that's not a polynomial, but that's okay for our purposes. This works just fine. And the last one, 4. What's the degree on that? 0. I have no variables. It's a degree 0. Okay. Here's the tricky part. This is the new big thing we're learning today. One that's going to cause the most problems the next few days, but it really isn't that hard. Adding and subtracting polynomials. You have to know their names, but you also have to be able to add and subtract them. When you add and subtract, exponents do not change. Exponents only change with multiplication. If you're adding and subtracting, you do not change powers. First thing, students love to change powers when we're adding and subtracting. You do not change powers when you are adding and subtracting. You only change powers when you are multiplying. Now, when you're adding and subtracting, we combine it's combining like terms. We've done some of that. I can only add things where the variable portion is exactly the same. So like on this one, I have x squareds. I have 3x squareds, I have 5x squareds. How many x squareds do I have? I have 3 bananas in this hand, I have 5 bananas in this hand. How many bananas do I have altogether? 8. So I have 3x squareds in this hand and 5x squareds in this hand. How many x squareds do I have altogether? 8. 5 plus 3, 8 x squareds. That's how many x squareds I have. Okay. That's what it is. We're not making fruit salad. We're not putting them all together. We're keeping our apples and bananas all separated. We're keeping our x squareds and our x's all separated. Next one's a little more complicated because it doesn't look like ooh, I've got x cubes and I've got y's. Here's the thing. Is this and that the same? Are the variable portions exactly the same? I have x cubes and I have y's. I don't care about the number in front. I just care about the variable part. X cubed y. Yeah, that's exactly the same. How many x cubes y do I have? How many do I have here? I've got a 1 in front, right? How many of them do I have all together? 4 plus 1 gives me 5. Five x cubed y. Like I said, the variable portion does not change. You're strictly adding or subtracting the numbers in front, the coefficients that are in front. Variable portions don't change. When you're doing addition, the parentheses do not matter. You can just add or subtract as needed. So I look and I go, ooh, I've got 4x squared and 2x squared. How many x squareds do I have? Come on. 4 plus 2. This is a bad Monday. 4x. So I have 4x squared. 2x squared gives me 6x squared. And when I am doing them, I like to do this and cross them out as I go along. Next thing I have 6x and negative 9x. What's 6 plus negative 9? Negative 3. So how many x's do I have? I have negative 3x. And my x's are gone. And then what do I have left? What's 7 plus 1? 8. See? Piece of cake. So, same thing on this one. I go, all right. What do I start with? I start with 3y cubed. Do I have any other y cubes? Yeah. So how many y cubes do I have all together? I've got 3 minus 6 gives me negative 3y cubed. Now, I could go to the next term. However, we want to try and do this in standard form for our final answer. Go to the next power down. Ooh, 7y squared, 2y squared. How many y squareds do I have? 7 plus 2, 9y squared. Those are gone. Then I go, ooh, next one down, 5y, 7y. How many y's do I have all together? 5 plus 7 is... Oh, there we go. Somebody else other than Noah. Plus 12y. And those are gone. And then, what do I have left? Negative 9. See? Piece of cake. Combining up like terms. I have negative 3 bananas. I have 9 apples. I have 12 kumquats. And then negative 9 kiwi. I don't put them all in the same bowl. I don't want mixed salad. I want them all separated. Okay. Subtraction. Same thing. When you have two terms, it's easy. 4xy cubed minus, how many x cubed y's do I have here? I have one of them. What's 4 minus 1? 3. So I have 3x cubed y. Now, the next one is a little more difficult. What am I subtracting? I'm subtracting everything in the parentheses. If I have a minus in front of parentheses, I don't like to do that. Here's what you do. Take this subtraction, make it addition, and change the sign of everything in the parentheses afterwards. Take that subtraction, make it addition, and then change the parentheses and everything afterwards. Okay? And now I can combine up my like terms. I do exactly what I did up above. So my largest power is to the fourth. I have 2m to the fourth. Do I have any other m to the fourth? No, so there's nothing to combine it with, so I just have 2m to the fourth. And then I have a squared here, but I do have a cube down here. Do I have any other m cubes? Well, makes it easy. Negative 7 m cubed. What's next? Yeah, so I have 5m squared. I don't have any other m squareds. Oh, that's nice. Plus 5m squared. I haven't had to really do any hard work yet. And then I have negative 8m. And then I have plus 9m. What's negative 8 plus 9? 1. So I have how many m's? I have 1. And then I look at my last things I have. Negative 7. And then remember I changed this from a plus 6 to a minus 6. I have negative 7, negative 6. Combine them together, I get negative 13. Any questions? So your classwork today, naming things, writing them in standard form, adding and subtracting.